Okay, I think we can start our next presentation. So this time we have two presenters. So Leo and Hrvoje will present their talk, and I guess they're really busy because they're both students at RIT, but also working for private companies. So was that why you split the talk in two? Or okay, the floor is yours.
All right. So thank you very much. So we're going to be talking about two research projects we did. Oh, thank you. One being about HTTP 1.1 versus HTTP 2. That's what I will be discussing. And my colleague Hrvoje will be discussing the 3 new garbage collectors that come with Java 9. With mine, there was a bit of talk about Java 9. However, at the time, Java 9 was still in alpha, and there were some issues with experimenting more with that. So on the agenda, like I said, we'll be going over the overview of what exactly we studied. Let's see if I can figure this out. Excellent. What we studied, I'll be talking first about the issues of the first version, what the new one hopes to fix, and how they fixed it, at least theoretically, how I did it and the results. My colleague will also be going over his goals, the different garbage collector, the concept of the heap, as well as his benchmarking and conclusions. So, gotta get used to this. So I'll be starting first, obviously, that's why I have the mic. So first, the research overview is why I did this, is I wanted to see why is there a version 2 of the HTTP protocol being released? Why is there 1.1, and what is Speedy, which is what Google first implemented? If you'll see on the far right, you see the Speedy HTTP 2 logo. Google was a big factor in pushing forward version 2, because obviously they're a large web company. HTTP 2, I'm just going to call it version 2 because I'm stuttering on it, was actually based off of Speedy, and they had a lot of push with pushing through the different RFCs needed to get this protocol sent to public. So I also, as a secondary thing, wanted to investigate how is this version 2's use in Java 9 to see how mature it is and what can be done with it. So before I continue, I'm going to talk a little bit about what's wrong with version 1.1, is what exactly is the issue. And the first one is head of line blocking, which you can actually see here. Let's see. Let me just switch this over. There we go. You can see here this diagram that shows what it is. Essentially, with these, you see there's request A, B, and C. And on the right, you see again just with arrows represented instead. Essentially, head of line blocking is when one request comes and takes a large amount of server time, and other requests are forced to essentially wait in line in order to do anything further down the line. And this is, of course, a problem if you have a very large packet or if the server for some reason slows down due to some request, I should say. And this has always been a problem where fat packets can slow things down. You had uncompressed headers, which is, I think most of us here probably know that when you send a TCP IP packet, you're sending header information constantly, which means you're going to be sending where the request is coming from and where the request is going to constantly and over, which is wasteful. And the last is the slow start mechanism, which Google actually managed to change while they were fighting for version 2. Originally, you could send 2 packets at once, which is about 3 kilobytes of data from 2 different ones. And it would slowly, or not slowly, it would exponentially ramp up in speed as it tested the maximum bandwidth of the system. The problem is that it's a slow start, so it starts slow, and Google managed to increase it from 2 packets to 10. Still not good enough, though. So with version 2, just a brief summary I can't go into too many details of the hacks that developers use to get around the issues. In version 2, there's a big change to a binary protocol now. Bit of a negative, it can no longer be used with telnet. However, now it's no longer plain text. There's HPAC header compression, so the headers are compressed when they are sent. And there's also the implementation of dynamic tables, as they call them, which is actually just pointers. If a header field is the same as in another packet, one header or one header field will just point to another and say, please refer to the first packet you received. There's the new server push functionality, which is just a server is able to proactively send data to the clients instead of being requested. So when you connect to an HTML page, for example, the server can say, you will also need this bundle of packages all at once. And also there's the addition of multiplexing with flow control. Essentially now clients and servers are able to talk and send and receive at the same time. In addition, flow control is there for the server to dictate how much the client can request from it in case it's under high stress. So I wanted to see the differences in performance, and so I decided to be more practical since I found other studies that essentially broke an image into 100, 200 files and sent them over over a server. Instead, I cloned 15 popular websites, not including google.com because the main site is very small. And I hosted it locally over a Jetty HTTP2 server. I chose Jetty just because Tomcat had only just released version 2 support during my research, and this was more full-featured at the time. So I used this, I hosted it on a virtual machine as well to induce latency, and I also emulated a 4G connection using Chrome's developer tools. So essentially, when you look at the graphs, there's actually not a huge difference when all you do is change the protocol itself. In fact, the only website that gained anything substantial is on the far right, which is actually Yahoo. They gained, let's say, about a 10% improvement. All other websites either saw a reduction in performance, or they saw no increase whatsoever. I'm sorry, I should mention. Blue on the left, version 1, version 2 on the right in orange. So this is just on the local host being sent through, of course, just on my computer. When I introduced to see what would happen if it goes over a virtual switch to a VM instead, also a Jetty server, essentially the only big difference is Yahoo lost its lead. Everything else also just didn't gain anything. The worst is the IEEE site actually lost performance when switching to version 2. And I ran each of these websites 10 times and took the averages to see if there was any difference. So in my conclusion, essentially version 2 doesn't seem to be a magic bullet. What I was reading during my research was, if you switch to version 2, expect 40 to 50% performance, minimum 20%. And I wanted to see, is that true? Didn't seem so at the time. So when I looked at version 9, it was still in its early stages, which I found. That's why I was stuck with the Jetty instead of Tomcat. And basically, that's what I found out with mine is, it's no replacement for good site design and properly making your website. So that's it for my part, at least. Next will be my colleague Hrvoje, and talking about garbage collectors.
Hello, everyone. Thank you, Leo, first of all, for the kind introduction. I'll be talking about a bit different aspect of the application development. This is some aspect that we Java developers often take for granted, as often Java does pretty good job for us without us having to do any kind of tuning. But nevertheless, there are still some challenges that we wanted to compare. So to give you a brief overview over our research is that we were intrigued with the decision that in Java 9 they are switching actually the default GC to garbage first. So we wanted to see how this new garbage collector is handling previously widely adopted parallel GC and CMS GC. Our entire research was based on comparing performance in the amount of time they need to execute garbage collections and the actual amount of times how many GC requests are being handled. So our research was focused on 4 main goals. First of all was to find a suitable benchmark that could replicate real-world applications. We found such as DaCapo benchmark suite that holds, I believe, 10 applications that create non-trivial memory pressures to the GC. We focused on conducting tests using out-of-the-box settings because we wanted to see how the performance is purely out of the box, so without any heavy JVM tuning or actual GC tuning. And as I said, we focused on determining the number and time necessary to execute GC operations, and finally to evaluate, does the differences in heap architecture play any major role? These are the garbage collectors that we used. So if there's a lot of background information on those garbage collectors, but I'm gonna keep it very brief. So if we compare G1 to the parallel or CMS, the entire design at hand is completely different. So parallel GC and CMS GC were, so for example, parallel, if we have a task that is that has a lot of things to do, processing, it's good to use it, but only if you don't mind the latency, because parallel GC has some nasty tendency to create a lot of latency. So it's maybe applicable in tasks like formatting billing reports or executing some big batch transactions. CMS, on the other hand, is very handy if you want it running alongside your application, because it's very low latency. But this concurrency creates a lot of processing, uses a lot of processing resources. So it's by far the most consuming GC out there, but you have low latency. So the idea with the G1 was to actually bridge those two gaps by offering at the same time predictable pause times that would reduce in lower latency, but again, having higher probability of throughput. So G1 achieved that, or tries to achieve that, with a completely different structure, architecture of the heap. So on the left here, you can see how the traditional heap, generational type of heap looks like. It's basically very segregated in those generational types where new objects get created in young area, then if they live long enough, they get copied or get erased. G1 takes a completely different approach. So the heap space is not divided so on age, but more in a logical sense. And what is great about it is that even though those smaller heap areas start equal, they are not fixed in size. So it's very scalable, and this helps to improve the performance. However, this is how our benchmarking process looked like. So we selected 6 applications. We ran each application for 20 times, and then we measured the results in a chart-like structure that makes it easy to compare the actual performance. So I think you can see that, but the blue thing is the G1, and the other 2 colors are CMS and parallel. Results were not that promising for the G1. But I mean, I have to say like a disclaimer, like in the commercials, if you look through the specs of the G1, they really say it's a garbage collector intended for like big production systems that have a lot of memory, a lot of processing power, and we had a limitation of our academic settings, so we used our personal computers that did not maybe offer such capabilities. Anyways, in 4 out of 6 cases, the G1 performed equally or worse than the parallel or CMS. However, we noticed an interesting thing, that when we were running on applications that heavily rely on multi-threads, G1 actually outperformed the other 2, or in worst case was equal with them. So in 2 cases we had similar results, and in 2 cases it was much better. So the things to consider if you think on changing your garbage collectors, I mean if you plan on switching, is really you need to test it. You need to test how your application is dealing with the architecture that's behind the algorithm that will be doing the garbage cleaning. Next, if you're in an early planning phase, you can like think ahead and structure your application in a way that would really satisfy some criteria that would optimize the performance. And especially what was out of the scope of our research is invest time and effort into tuning of the JVM. There is some great research that we discovered along the way that really automated this process and tries basically brute force style of numerous combinations to see which pattern of parameter is the best for your application, and in that way optimizes it. And the thing that I basically discovered before preparing for this talk is that in the next Java release, they're doing like a big update of the G1 garbage collector. So that's definitely a good foundation for any work in the future that maybe any of you might be interested in. Thank you. Questions? Okay.
I have one question. How is this to switch to the GC? What do you have to do?
It's not that hard. Well, basically, in our case, if we were running an application, we just needed to input some console parameters that would actually activate the preferred GC that you desired. But it's not that easy. It's not that hard. Sorry, not that hard.
And the same question for Leo. How easy is to switch from HTTP1 to HTTP2? What do you have to do actually?
It's only a configuration flag, at least in Jetty. Let's see if I can. So it's only, a configuration flag in the Jetty server. Now with Tomcat support, I imagine it's very similar. It's just does it support it, does it not. So.
One question for Leo. Have you tried it HTTP2 for REST APIs?
No, I did not try that, unfortunately. I didn't have time to finish that part of it. It would be interesting, though, to see how it would work actually in a, let's say, a large-scale application, for example.
Yeah, I think we'll see a much bigger difference there.
Yeah.
Question for Hrvoje. Which of the GCs is more influenced by software design of application? Which encourages better design?
Yeah, well, I cannot say for sure like this is the best or that's the best, but we saw that a lot of influence was played by the application architecture, especially if you have multi-thread environment that's very concurrent. In the cases of the tested applications, G1 outperformed in those conditions other two. So I think it's important, but the way how you can determine that is basically by testing. You need really just to invest time and effort to test those cases and to see which one plays the best for you. And it's, as I said, it's not that hard to switch them, to put some parameters that are applicable to your case and to see which is best for you. Also, the tool that we use is very convenient. It's called Visual VM by Oracle, so it's very easy to track those things.
So if we had a Jerry HTTP2 server, or let's say Tomcat, so which garbage collector would be the best choice for you?
I mean, again, it's very relative. So you really need to test what your intention for the application is. But I would say that if you're running a big enterprise system that has a service that needs to be like constantly available or something like that, well, G1 is they advertise for. So because of that continuous availability, it will both run concurrently with your application, and it will give you enough of throughput that your users do not experience any bad UI, or that even that you don't reach some critical failures because of memory overload. So.
And which framework does that support for HTTP2?
I actually haven't used any of the newer frameworks that would have support for it. I imagine now it's becoming far more commonplace, although I couldn't give you the exact ones. I know, like I said, Tomcat now has it, and Java 9 about, I think last year in September, finalized their HTTP2 client. From what I saw, Spring now has support for it, but I have not used it, so I couldn't tell you how good it is, unfortunately. Thank you all very much for your time.
Yeah, thank you.
Okay, we have the next slot at 12:25, so we have some time to stretch your legs.